Ask my instructor 8.4.25. Evaluate the following integral. First thing I'd like you to notice is that x squared is made up of repeated linear factors. It is not an irreducible quadratic. These are three examples of polynomials or monomials that can be broken up into repeated linear factors. And then at the bottom of the page we have an irreducible quadratic factor, x squared plus 5. It's called irreducible because you can't break it up into smaller linear factors. And why do we care about the difference? Well, the way that you handle a repeated linear is different from how you handle an irreducible. This is how you handle a repeated linear. Notice that you need two partials for the factor x squared, and then just one partial for the factor x plus 2. We're going to multiply both sides by x squared times x plus 2. This will eliminate all the fractions. After you've done that, turn the video back on. Next, I'd like you to distribute. Turn off the video and then turn it back on when you're ready. The next step is for you to collect all the coefficients of x squared. And I get a plus c. Now collect all the coefficients of x. And I get 2a plus b. Notice that there are no terms involving a quadratic on the left-hand side. And so on the right-hand side, the coefficient of the quadratic must be 0. The term involving x on the left-hand side, the linear term, has a coefficient of 8. So the linear term on the right-hand side must also be a coefficient of 8. The constant on the left-hand side is negative 12. So the constant on the right-hand side has to be negative 12 as well. And that gives us three equations. Three equations and three unknowns. We are looking for three values, A, B, C, where all three equations are true simultaneously. The three values have to make every single one of those equations true. I always start with the easiest equation. How do I make this third equation true? Well, it's only going to be true if b is equal to negative 6. So, b equals negative 6. All right, well, if b equals negative 6, then that negative 6 has to be true for the second equation that has a b as well. So basically I'm looking for every instance of b, and every time I see a b I'm going to put in negative 6. Once I have made my change, it becomes, this second equation is going to be the next one to examine. Why am I choosing the second equation? Well, if you look at it carefully, you'll see that there's only one variable involved, and that's the easiest type of equation to solve. So I solve for that second equation, and I get a equals 7. So I have b equals negative 6, I have a equals 7, and so what does c have to be? Well, put a into my first equation. and this is what my first equation will look like, and I solve for c, and it's probably no shock to you that c would have to be -7. Next, it's something that we have to discipline ourselves to do, but it really is a good idea to check our work. So if my top equation is true, if I have done everything correctly, then I should be able to go through the process with all these numbers and everything fall out nicely. So I start with my first equation with my values of a, b, and c put in. Then I multiply both sides by x squared times x plus 2. And then I notice that I have 7x squared and -7x squared. Then I combine my 14x and my -6x, and I get down to a statement that tells me I did everything right. I'm going to use this information to set up my integral. Sometimes for me it's easier to do the integrals separately. When I do the integrals separately, I only need to focus on one piece at a time, and when I do it that way, I wait to add in my arbitrary constant for later in the problem. So the first one, 7 over x, is a log. 6 over x squared, if you rewrite it as 6 times x to the -2, you see that it's a power problem. And then the third one is another log. All right, so on the third line, this is where I add my arbitrary constant. Next, I need to do a little bit of cleanup. Notice how I've got log written twice. I want to put those together. So first I just put them side by side. Be very careful that you don't lose any sign values. And next I use my power rule, and then finally I'm able to put it together using the subtraction rule. And this is my final answer.